This is Lily. Lily is a witch, but not just any kind of witch. Lily is the daughter of Harry and Jenny Potter. Her parents are practically royalty around here, but that's a story for another day. Today, we're talking about Lily and her most prized possession, her spellbook. Passed down through many generations of strong and powerful witches, this magic spellbook contains some of the witch world's best-kept secrets. What could possibly be so powerful that witches must keep it a secret, you may ask? Well, none other than the magic thermodynamic square, of course. This thermodynamic square is a mnemonic diagram that tells us about a series of spells that describe pretty much everything we would ever need to know about thermodynamics. Don't believe me? Let's take a look. We can start by orienting ourselves and noting that each side of the square has an energy, and each of those energies is flanked by two of the most important natural variables. For example, internal energy is positioned between entropy and volume, serving to describe their natural dependence on one another. We can also see that conjugate variables occupy opposite ends of each diagonal. Crossed arrows point toward volume and temperature and away from entropy and pressure. We can also cast a spell to determine the thermodynamic identity for each energy. To do this, we must choose an energy and follow the nearest arrows to its natural variables. We then follow the diagonal arrows to each of the conjugate variables. Additionally, the directionality of the arrow will tell us whether this relationship is positive or negative. For example, we can see that the thermodynamic identity for internal energy is spelled by the derivative of internal energy is equal to TdS minus PdV. And this is negative because the arrowhead is pointing away from pressure. Lily's favorite spell in the book is one that describes a partial derivative, or the variation of Gibbs free energy with respect to temperature at constant pressure. For this, we would use the partial derivative of Gibbs free energy over the partial derivative of temperature at constant pressure, which is equal to the diagonal, in this case entropy. This value is negative because the arrowhead is pointing away. And finally, and perhaps the most complicated spell detailed by the thermodynamic square, depicts the Maxwell relations for each of the energies. In this spell, we can find an alternative set of variables that allows us to find the variation of temperature with respect to volume at constant entropy. Looking at the square, if we start at our desired value of temperature and move toward where it has its dependence on volume, we can continue moving in that direction to past our fixed entropy and wind up at pressure, or our turnaround point. We would then move backwards, passing entropy again and ending with volume. This would give us the ultimate Maxwell relation of the partial derivative of temperature over the partial derivative of volume at constant entropy is equal to the negative partial derivative of pressure over the partial derivative of entropy at constant volume, where the right side of this equation is negative because the arrowhead is facing away from pressure. And there you have it, a peek into Lily's family spellbook and a glimpse at just how powerful the magic thermodynamic square really is.